All right, kids. What this video is going to do is talk about topic 8 for polygons on the coordinate plane. What you'll want to do is open your book up to pages 216 and 217. I'll let you pause the video while you do that. Now, before we start talking about the polygons on the coordinate plane and going over what's in the book, I want to give you some basic background information to start off with. Now, here are some of the basics to begin with, okay? Polygons on the coordinate plane will have letter names. These letter names would be an example like this: rectangle ABCD, okay? So if we were to name this rectangle over here, we would name the points A, B, C, and D. So we're going to just go around the perimeter of the rectangle. This is going to be point A, this would be point B, this would be point C, and this would be point D. And that is how you get the name rectangle ABCD, okay? Now, these letter names will all have locations based on coordinates. So one of the things that it's nice to do is kind of to take a look at our coordinates for each one of these, okay? So the coordinates for point A would be -2, +4. For point B, we would have +3, +4. And so what you can do is you can actually identify quite a lot of information just by looking at the coordinates of each point. So for example, you'll see that they have different x values and they have y values that are the same. So that means that line segment AB is parallel to the x-axis. And that's kind of important to think about because as you can see as I slide it up, it also means that line segment DC are going to be parallel to the x-axis. Okay? So knowing that they both have the same y coordinate, you know that they will be parallel to the x-axis. Now, you can also tell that they are in different quadrants because this is a positive and this is a negative. So these, you can then know that if you're going to find the distance from here to there, you're crossing an axis, which means you're going to be adding the absolute value of those two numbers, okay? So you can tell a lot by that. If we look at the coordinates for D and C, we'll see that C has the coordinates of +3, +1. And then you'll look at D and you'll say D has -2, +1. And again, you can see that they share the same y value, which means that they are going to be parallel to the x-axis, which is good because now we know that line segment AB is parallel to line segment DC. And that's good information to know because we're talking about rectangles. Now, interestingly, if you look at line segment AD from here to there, you'll notice that those two coordinates, they no longer share a y value, they share an x value, which means that they are going to run parallel with the y-axis. So they will run parallel with the y-axis. And that's what you have there. You'll also notice that they are in the same quadrant, okay? They have a +1 and a +4, which means they are in quadrant 2, which means when you figure out the distance, you'll be taking the absolute value and subtracting it in order to find it. Okay, and so likewise you can see over here that they have a common x value and they have different y values, which tells you that you again have 2 points that are in the same quadrant and that you want to find the distance by subtracting absolute value. All right, so that's some basics. The other thing to remember is that the coordinates can help you identify sides as either the length or the width. So you can actually use these letters. So for example, you could say AB and CD will be the lengths, and then BC and AD will be the width. So you can use these to help you decide which is length and width. All right? So anyways, in your book, when you're going over the information, they again will present you with a situation. How can you find the perimeter of a polygon on a coordinate plane? Remember that perimeter is the distance around something, okay? And they're talking about on a coordinate plane. An archaeologist used a coordinate grid to map a dig site. She marked the corners of a building with flags as shown. How much rope does she need to go around the building? Well, here's your clue. In this question, she's talking about rope, so linear distance, and to go around a building, so you're talking about perimeter, okay? And it just so happens that here are the points, and if you connect them, A, B, C, D, you get yourself a rectangle. So again, what we have is we have a coordinate plane, and we notice that we have two line segments, line segment AB and DC, cross the y-axis. So in order to find this distance, we're going to get absolute values and add. BC and AD, BC, line segment BC is in, both points are in the same quadrant. Both points are in the same quadrant, so absolute values and subtraction. All right? So then we go on and it begins to explain it a little bit to us. To find the length of each side of a rectangle, ABCD, use the coordinates of the vertices of the rectangle. So in other words, what they do in the book is they say, okay, the points for A, in order to find A, you would have -4, +6, and that's point A. Point B is +6, or +2, +6. Point C, the coordinates are +2, +1. And D, you can see that you have -4, -1. Okay? So we use the coordinates to find the vertices. Now the first thing that we're going to do in this case is we're going to establish a length. So we're going to use point A and B to determine a length. So we're going to want to find that distance from A to B. Okay, so we want to find from A to B. So what we're going to do is we're going to take the coordinates from A and the coordinates from B, and we say, okay, they are both on the same y value, so we're not going to use the y value. That means that they run parallel with the x-axis. Okay, so our distance is going to be from A to B, and remember, it crosses over the y-axis, so we're going to use subtraction. So what we do is we take the -4's absolute value and the absolute value of +2, so we take the two absolute values from the x number, and we use those to determine a distance. So the distance will then be 4 + 2, because the absolute value of 4 is 4, or -4 is 4. The absolute value of +2 is 2. 4 + 2 = 6. So we know that this distance from there to there is going to have a value of 6 units. Okay? A value of 6 units from there to there. Then we also know that if this distance is 6, the distance from D to C will also be 6. Okay? So what we want to do then is ask ourselves, well, what is the distance from B to C? Because this is our length, and then if we know our width, we can start figuring out perimeter. So what we'll do is we'll say, okay, here are the coordinates for B, here are the coordinates for C. You can see that they both have 2 as the x value, so we're going to be working with the y values. And we want to do the absolute values of the y's. So down here, we're going to take the absolute value of 6 and the absolute value of positive 1, and we're going to use subtraction. And the reason we use subtraction is because those points are in the same quadrant. They don't cross an axis. So now we're going to establish that distance by doing 6 minus 1 equals 5. So this distance from B to C, this distance from B to C is going to be 5 units. Okay? So now that we have this length and this length, we can figure out the opposing lengths. Of course, because these points are both parallel to this axis, we know that this distance and this distance are going to be the same, so that's 6. And we know that this distance over here will also be 5. So now we can determine the perimeter. So all we have to do now is worry about adding those amounts up. So we can take 6 plus 6, which equals 12. And we could have multiplied 2 times 6. That's fine. That works well also. And then 5 plus 5 equals 10. And then we add those two amounts together, and we get a total of 22. So the perimeter of this rectangle is 22 around it. Okay, 22 feet, unit meters is what they're calling it. So that's what we would go with. All right. So anyways, that's how you find perimeter using absolute values and the points on a grid. Here's a practice problem. Why don't you, this is number 1 in your book, why don't you see if you can find the perimeter of a rectangle, MNOP, using these coordinates, and then I'll go over it with you. So why don't you pause the video while you solve that problem. All right, here we go. Let's take a look at what we have here. Well, the correct answer for this is 28 yards. Now, how do you get 28 yards using these coordinates? Well, the first thing you want to do is you want to find a length. So you have to decide which of these you're going to pair up. All right? In this case, what I did was I paired up M and N. They both are going to fall on the -2 on the x-axis. So that means that they're going to be parallel with y, okay? And so what I'll do is I'll simply say, okay, I'm not going to use the x value. I'm going to use the y values. So I'm going to find the absolute values. So I'm going to take my point M, and I'm going to use the absolute value of 5. I'm going to take my point N and use the absolute value of 4. Now, once I find these absolute values, they will be positive numbers that I add, and I get 9. The reason I'm using addition is because they are in different quadrants. We know they're in different quadrants because you have a negative, positive, and a negative, negative. So this is going to be in quadrant 2, and this would be in quadrant 3. So in order to get from this point to this point, you're going to have to jump over the x-axis. So our length is then 9. Okay? Then we have to establish a width. Well, in order to establish a width, what I'm going to go with is I'm going to go with point M and point P. So if you could envision this, okay, I would then take my values, again, my coordinates for M, which would be -2, +5, and then my coordinates for P, which is +3, +5, and I'm going to eliminate the common number, which is a Y value this time, and I'm going to then combine these absolute values into the operation that'll give me distance. Now, in this case, I'm going from a negative to a positive, so I know that I have to add again. So I'm going to take the absolute value of 2, which is 2, the absolute value of 3, the absolute value of -2 is 2, the absolute value of +3 is 3, and I add them together and I get 5. So 5 is the width of my rectangle. So now I have my length and my width. So in other words, I can now say to myself that I have my width, and it is my length, whatever my rectangle might be, is 9, and its width is 5. It could look like this. It could be turned any way I want. And I know that this will be 5, and I know this will be 9. And so now all I have to do is add those amounts up. I could multiply by 2. That would be 18. This times 2 is 10. So my distance is going to be 28 yards. And that's how you would come up with that, okay? By simply using absolute values. All right? Okay, let's take a look at another problem. See if you can answer 3 and 4. You can pause your video and then start it up again. All right, writing to explain. Could you use the method of adding or subtracting the absolute values of coordinates to find the length of the diagonal AC of rectangle ABCD? Explain why or why not. Well, notice what they're asking you to find. They're asking you to find the diagonal of rectangle ABCD. So if we were to draw a rectangle, name the points A, B, C, and D, they want to know if you could use absolute values to find the length of the diagonal AC. So the diagonal AC would be from there to there. And in this case, the answer is no. You could not use the absolute values to find that. And the reason being is because this distance is going to be longer if you look at it. If you take that distance and you turn it, it doesn't fall on any coordinates or anything like that, and it's actually a longer distance. So the answer to that is a definite no. And the reason being is that diagonals from point to point don't fall within the coordinate plane in terms of actual units up and down, so absolute value is not going to work in that case. All right? Number 4, think about the structure. In the problem above, why does CD equal AB? Well, line segment CD, okay, from there to there, okay, is parallel with that and that. So therefore, they are going to be equal in distance. Okay, take a look at number 9 in your book and see if you can solve this problem. Go ahead and pause the video and see if you can come up with an answer. All right, here we go. Mike used a coordinate grid to design a patio shown at the right. The units shown on the grid are yards. To buy materials to build the patio, he needs to know its perimeter. What is the perimeter of the patio? Well, in this case, they pretty much give you everything you need to know, and you could do the addition if you want over here. You'll notice that it is all in the same quadrant, so you're going to be subtracting in order to find distances. So in this case, you would be able to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18,